Hi everybody, Jeremy Blum here, back with Eagle tutorial number 3, the much anticipated third installment, in which I explain how to generate a bill of materials and how to generate the output board files called Gerbers that you can use to get your circuit board that we designed in episodes 1 and 2 actually manufactured. We'll also talk about design for manufacturing and how to make sure you meet all the design requirements and constraints that are set by your particular board fabrication house. In this episode, we won't go into manufacturing the boards yourselves using laser printing or other techniques like that. If you're interested in that kind of thing, I suggest you Google around for it. There's simply too many to cover in one video. As a reminder, you can get all of the accompanying material that goes with these videos on my website, jeremyblum.com. You'll also find them linked from the YouTube videos, and they're also available as downloads as an entire GitHub repository on my GitHub page. Also, if you support the work I'm doing, don't forget that I also just wrote a book, Exploring Arduino, teach you all about Arduino and all the fun things you can do with it. It's available worldwide in both hard copies, PDFs, EPUBs, Mobis, Kindle, Barnes & Noble, Nooks, all that good stuff. So go ahead and take a look at it if you want to help support the work I'm doing. Okay, that's enough of that. Let's get started with getting our board ready for manufacturing. Now it's time to generate a bill of materials using Eagle's built-in Design Link tool. The Design Link tool makes it easy to go through all the parts that you've specified in your schematic and your board layout, and to generate a parts list that you can then order from Newark Element 14. Of course, you can also manually generate a BOM for DigiKey or Mauser or any other electronics distributor, and I'll often do that. Or you can also go find plenty of user scripts that plug into Eagle that generate BOMs for all kinds of suppliers. But we'll use the Design Link tool because it's built in and it's pretty easy. Remember, to switch back and forth between your schematic and board layout, you can click this little button on the top left corner. So go to the schematic, and next to Design Link, click the little drop-down arrow and choose Schematic. What this will do is it'll go through each part that you specified in your schematic and allow you to add a part to your, essentially, your shopping cart or your bill of materials for that part. Keep in mind that the search is not always super accurate, and sometimes it helps to kind of put in your own search terms. We'll have to do that a bunch here. So for example, with the battery, it's searching for an actual battery instead of an actual holder, which is what we want. We want the holder. So let's search for a 12mm coin cell to see if that finds what we want. Okay, that's not it. Nope. Okay, there we go. That looks like it. That's our little battery contact 12mm cell, surface mount, perfect. Hit select and it'll add it. And that's actually adding an attribute to the part on your schematic that can then be generated into a bill of materials. Next up, we have an 0805 22 microfarad capacitor. You can see down on the bottom here that it specifies the value and package of the part, which is really what we care about. Okay, this is a 20%, 0805, 22 microfarads. There's plenty of them available, and they're about 51 cents each. That looks pretty good to me, so hit select. Next up, we're looking for a 0.01 microfarad capacitor. Now, none of these look like quite what we're looking for. We want a surface mount one like the one we just picked. So let's try looking for 0805 capacitor. See if that gives us any better luck. Alright, that's looking a little better. At least that's a surface mount capacitor now. It doesn't say anything about the package size though. We can see the package size in the description in a lot of them here. 0201 is too small. We're using all 0805 in our board layout, which is a larger surface mount part. None of these seem to be the right size. So another methodology that you should become familiar with for capacitors is making sure you put in the right units. So we specified it as 0.01 microfarads, but that can also be written as 10 nanofarads, which maybe we'll have better luck finding a 10 nanofarad. Okay, here are some 10 nanofarad 0805 capacitors. These are rated up to 250 volts. That's kind of overkill. We can reduce the price by about 3 times if we go down to 50 volts, which is still way more tolerance than we need. That's fine. Usually you want the capacitors to be rated for at least twice the voltage that you think they might see. And this is going to be well under 50 volts, around 3 something volts, so we should be fine there. Okay, this looks pretty good. It's about 1 cent apart. There's plenty available. You always want to check to make sure that there's lots of quantity available for the parts so you don't run out. Okay, that looks good. Let's select that. And if you're not sure about doing the conversion, remember, you can just go to Google, type in 0.01 microfarads in nanofarads, and it'll do the conversion for you. So we can see I've already pre-calculated this. That's 10 nanofarads. Okay, next up is our 0805 green chip LED. Obviously, just searching for the word green is not going to be very helpful here. So let's search green LED 0805 surface mount device. SMD means surface mount device. Okay, here's one. It doesn't specify the package size, so let's see if we can find one that explicitly says it's 0805. Here's one where there's no photo. There's also none available, so that's no good. If we scroll down to the bottom, here we go. Here's one with about 3,000 available, 14 cents a piece, 0805, green, 450 millicandelas, so decently bright, 520 nanometers, which is in the green wavelength. Okay, this looks good. Let's select that. Okay, next up, we're looking for an 0805 100 ohm resistor. Obviously, again, searching just for 100 is not going to be super helpful. It's not the most intelligent search script in the world. So let's say 100 ohm resistor 0805. Let's see how that does. Okay, here's some 100 ohm, 250 milliwatt, 1%. Doesn't say the package size though, so let's see see if we can find one that explicitly says that. Here we go. This one's 100 ohms, 5%, which is close enough for our needs. 0805 package, about 1 cent a piece. Perfect. Let's add that. Okay, next up we're looking for a 100K resistor. So we'll search 100K resistor 0805. There we go. Now these actually look like resistors. So here's 100K, 100 milliwatt rating, 5%. Oh, there's none available though, so we don't want that. Here we go. Here's one that looks good, but this one's a lot cheaper. This one, but it doesn't say the package size. You can guess that it's 0805 from the name here, but just in case you want to be careful, that's okay too. We can also see that the minimum order quantity here is 5,000. We probably don't want 5,000, so you're going to want to keep your eye on stuff like that. If the price seems too good to be true, that's probably because they expect you to order insanely high quantities. Okay, so back to this one. This is 100K, 0.1 watts, 0.1%. That's frankly more accurate than we need it to. We can probably get something cheaper if we go for lower accuracy. That's a full reel again, 5,000 quantity. This one has a minimum order of 5. That's a little bit more reasonable. That's a minimum order of 50. This guy looks pretty good. 5,000 available, less than a cent each. 100 milliwatts, 100K resistance, 0805. They're in stock, minimum order quantity is 1. Perfect, let's select that. Okay, next up we've got a 1K 0805 resistor. Alright, in our first hit, that looks pretty good, less than a cent. Check that it meets all of our specifications, 1%. Again, we are pretty sure it's 0805 from the fact that it's listed there, even though it doesn't explicitly say it. Minimum order quantity is 1. Perfect, let's get that. Okay, and that's it. So it's generated our bill of materials. Now sometimes it might skip a part for one reason or the other. Basically, if it tries to do a search and can't find anything. And it looks like that's what happened with our 555 timer. That's obviously a very important part. So if we double click on that, yeah, so it couldn't find any parts. That's why it skipped it. So let's do a manual search. Let's just try to remove LM because we don't actually care who the manufacturer is. All 555 timers are pretty much the same. So here's one that's made by Texas Instruments, so a different manufacturer than we anticipated, but that's not a big deal. It's still 555 timer, they're all the same. It's an 8-pin SOIC, so the same package size. So that sounds pretty good. This guy is a dip version, so through hole. Here's another one, but there's no quantity in that. Here's another one from Texas Instruments. This one's rated up to 16 volts. Here's one from National Semiconductor. So it's kind of up to you to just kind of pick one that makes you the happiest. This one has a quantity of 0 though. Remember to keep an eye out for that. $15 volts, lots of options here. Kind of pick whichever one looks the best to you. So this guy is a 555D. That's what we were expecting to use. Up to 16 volts, 8-pin SOIC. We should be able to get the data sheet just to make sure it checks out against what we're expecting. So there we go. There's our package view. We can confirm that it matches up. This is always a good idea, that it matches up with what we expect. We can go, I won't do this right now, but you can go look at the package and make sure the pins match. And we can go through the data sheet and make sure it does everything that we expect it to. This is good. The threshold voltage is a function of VCC, so regardless of what battery voltage we're running at, it should still work, which is good. Supply voltage can be up to 18 volts. That's going to be a problem. So if we look at this particular part, supply voltage has to be at least 4.5 volts, but our battery is a lithium-ion battery that's running at about 3 volts. So this part is not going to work for us. So it's a good thing we checked the data sheet. So let's keep looking for other options here. It may help to sort by availability so you can see which ones there's a large quantity of. Oops, before we actually select it, we should look at the data sheet. Sometimes it can be hard to find the exact parameter you're looking for. Here we go. Okay. So this one, the TLC 555 from Texas Instruments, has a single supply operation from 2 volts up to 15 volts. This is important. Remember, we're using lithium-ion batteries, so we want to make sure that we get one that can operate at our supply voltage. So we keep going through. All of our threshold voltages look like they're pretty reasonable. Okay, this guy looks like a winner. So we'll go ahead and select this one. Okay, now we've officially created our bill of materials. As you can see, all of our parts are available and in stock. That's always very good. We can add them to our shopping cart directly. We can choose how many PCBs we want to make. So let's say we want to make 5 of them. We can update this, and you can see it updates the quantities accordingly so that we know we're ordering enough parts. You can go ahead and export this. That's always kind of a good idea. So you can export this as just a text file that contains all the information about your order. You can also hit add to shopping cart, and if you do that, you can see that they're all added to our shopping cart. Now, some of these have ridiculous freight charges, and that's a little crazy, so we might want to actually go through and adjust some of those parts. I'll leave that as an exercise to you guys, but you can pick out the parts that have those crazy fees and go back and adjust them accordingly. Just simply double click on them like this and pick another part that you think would work equally as well. As you could tell, there were many options for all of them. But that's it. So you've generated a bill of materials. It's already been added to your cart automatically, and you can go ahead and place an order for these. And you don't necessarily have to order it from element 14. because this has also generated the manufacturer code, which is really the important thing. And so this is the manufacturer part number, which makes it really easy to search for the part on other distributor websites. So that makes sure that you're not necessarily locked in. Now you can go ahead and look at that text file it just generated, and you can see that it's basically just a text representation of exactly what we were just looking at with the manufacturer code and information. Should make it easy to search for and find the parts you care about. Okay, so that's your bill of materials. Now it's time to move on to generating your Gerber files for your board layout. Now you're ready to generate your output Gerber files. Gerber files are a type of description file for your circuit board that you send along to a board fabrication facility so they can easily make your board. Each file that it outputs represents a different layer on the board. One is the top copper, one is the bottom copper. You have your silk screen, which is what your text is written on, and your solder mask and your drill layers. For more complicated boards, you might have multiple internal layers. You might have a paste layer that defines where to automatically put down solder paste if you're having your board assembled as well. But we're going to keep it pretty simple here. So first off, go ahead and make sure you're in your board view by clicking this button on the top left side. You may wish to calculate your rat's nest already if you haven't already done that so that it fills in everything. We already learned how to do this in the previous video. So your board's ready to go and you're ready to generate your output files. What do you do? So you're going to be using something called the CAM processor. You'll click this button on the top left side and it brings up this window. Basically now you're going to select all of the layers from within Eagle and how those layers from Eagle translate into layers for Gerber files. So you'll open a job file, go to File, Open Job, and so I have a particular CAM job file that I've created that I think works very well for two-layer boards. You can download it from the links in this video on my GitHub or on my website. It's a derivative of SparkFun's original CAM layout from their excellent Eagle tutorials. So you'll select that one. You can put it wherever you want. You'll just navigate to it, and when you hit Open, and choose that CAM file. So now what that does is it makes a number of tabs. Each one represents a different Gerber file that's going to be generated. There's the top copper, so that's the layer of copper that's on the top of the board. There's a layer of copper that's on the bottom of the board. The top silk screen. Note there's no bottom silk screen because it's only written on the top of this board. The top solder mask. So that's the green stuff that you see on a circuit board that covers up all the copper, except for the particular areas where copper is left open so you can solder things to it. Same thing goes to the bottom solder mask, and then the drill file, which specifies where the board fabrication house has to actually drill holes for your vias or through-hole components or actual drill holes like the one shown in the lower left-hand corner of our Blinky board. So for each one, you can see that a number of actual layers from Eagle have been specified to be added to the top copper Gerber file. So we've added the top, the dimension, so you generally put the dimension on every layer, and then the pads and vias, because pads and vias also represent copper that you want exposed on the top of the board. This is the device output type. You're going to stick with this for all of them. And then the file is going to be whatever file name you specified, and then this will be the extension. In this case, the Gerber top layer. Same thing goes to the bottom copper, except now we're looking at the bottom pads and vias. Here in this example job file, I'm actually only showing the dimension on the top copper, but it depends upon the board house. Some prefer different things, but this usually works pretty well. Top silk screen includes T-place, T-names, and T-values. So those are all, again, layers from within Eagle that we've used to specify our silk screen. Top solder mask is shown by T-stop in Eagle. None of the other layers are selected. Same thing goes for bottom solder mask, except it's B-stop. And then the drill file refers to drills and holes, and that gets output as just an ordinary text file. Okay, so once we've done that, we can go ahead and everything looks fine, so we can hit Process Job. That'll print all the apertures and generate output Gerber files. If you now navigate to where your project is located, you should see all of those files in place. So unfortunately, they kind of gotten buried here. I make them all capital so I can easily find them. So we've got GBL, GBS, GTL, GTO, GTS. Text is our drill file. Okay, and that looks like everything we care about. So text is our drill. We have our top and bottom solder mask, our top and bottom layers of copper, and our top silk screen. So why don't we go ahead and copy those into a new folder called Gerbers. Okay, and now these are all the files that you need to send to your board fabrication house. This is all you need. Usually you zip them up and send them off to your board fabricator. So let's look quickly at using, many board fabricators have online design for manufacturability checks. So a good example of one is Advanced Circuits, or 4PCB.com. So we'll navigate there and try out their design for manufacturability check service. Okay, so the Advanced Circuits is just an example of one of many PCB manufacturers. We can click here to basically get a quote, but you can see that they have free PCB file checks. They call it free DFM. So this is usually a good idea just to make sure that you're abiding by all of the rules of your appropriate manufacturer. So you just put in your email address. We'll zip these into a file first. So go ahead and send to a compressed zip folder, blinky.zip. Choose the file, find the zip, upload it. Okay, and now it'll ask you to identify all the file types. And you can see, because I use standard extension names here, it's already basically done all of it for us. As we expect, the Gerber bottom layer is the bottom copper, bottom solder mask, top copper, top silk screen, and we want to make sure that they know that this text file is an NC drill file. That's the only thing we need to change. You have 2 layers on this board. In order to get your X and Y dimensions for the board, you can go back to Eagle. If you click on PCB quote, this is a built-in tool for doing PCB quoting. We're kind of doing it the manual way because I want you to understand how it works. It'll give you the board width in here. So it's 30.46 millimeters by 50.47 millimeters. We're not doing an array or anything like that. You can leave all those things blank. Default for everything else is good. You're not subject to ITAR. That has to do with shipping electronics and things like that overseas that might be classified as military materials and things like that. So go ahead and hit submit. It wants this to be in inches. So go ahead and do the appropriate conversion. Okay, and you're all set. So they'll do an automatic design check for you and send you an email with information about whether it passes design for manufacturability. Note, this is specific to Advanced Circuit specific design capabilities for your board. It's going to be different for different board houses, but I wanted to give you an example of one. Lots of them have this kind of thing. So while we're waiting for that, let's talk about another way to view the Gerber outputs and make sure that they match what we expect them to. While you're waiting from your report from free DFM, it's also useful to be able to look at Gerber files yourself and to make sure that they match up what you would expect them to, because sometimes Gerber exports can do unexpected things. You probably won't have an issue with a very simple 2-layer board like the example that we're doing, but when you start doing more complicated designs, this is something you'll definitely want to check before you send your board out. I recommend the free ViewMate Gerber viewer from Pentalogics. There's a link to download in the description of this video. Make sure you just get the free version. You don't need anything complicated. Of course, it's going to actually do that annoying thing where it actually make an account, so go ahead and do that before you can download it. Once you've finished the extremely annoying install process for ViewMate, go ahead and open it up. Go to File, Import, Gerber, and let's go grab the Gerber files that we just generated. So don't worry about the drill files right now because that's not technically a Gerber file. We just want to look at the Gerbers. So let's open those up, hit import. Each one will get assigned to a different layer and color. You can double click on them over here to turn them on and off one at a time. So this is the bottom copper layer. This is just what we would expect. There's a ground pour, that's all this green area, that's all going to be connected to ground. And then these two traces here that have a nice clean separation from the rest of the ground pour. And then it's also routed out around where that hole is. So that's perfect. Here we have the bottom solder mask. Again, that's looking fine. That's where all of our vias are going to be, so that's perfect. Our top copper layer is now being added on top. Let's turn off the bottom so we can see it more clearly. These are where all the pads are for our parts, so that's looking pretty good, and all of our routing. Turn that guy back off. And here's our top silk screen layer. So this is where everything's going to be written on top. If we turn the top copper back on, you can see how everything overlays. In general, the board house will take care of removing silk screens that lay on top of exposed copper, like these guys to the resistors. So that's not an issue. And then if we turn on the top solder mask layer, we can see everywhere where there's going to be exposed copper with solder on it so that we can solder our components down to the board. So this looks good. This is all what we expect. And that's all ViewMate is. It's just to confirm that the Gerber files didn't export in some extremely weird or bizarre way. By this point, you should have gotten back your design check from free DFM. Again, this is just one of many DFM check services. But you can click here to view the DFM results for the files we uploaded. And now we can see that there's some showstoppers and things that were automatically fixed. So the things they automatically fixed are insufficient silk screen line widths. That's really not an issue. It means some places we made the silk screen pretty thin and they want it to be thicker to print it. They'll be able to automatically fix that when they fab the board. Showstoppers you have to be more concerned about. So here they said insufficient trace width, which is concerning because we made all of our trace widths the same width, very wide, by circuit board standards in terms of what's possible. So let's see what they were looking at here. And we can see very quickly that what they're actually talking about is our dimension layer that's going around the board. And if you look at all the places where they call it out and you cross-reference that with the board itself, that's all these borders around the board. Remember, we added those to the top copper layer when we output the Gerbers. And so, you know, different board houses do it different ways, but what you have to remember is that when you send files out to be produced by a circuit board manufacturer, there are actual human beings looking at them and doing these cam checks to make sure that it checks out. So something like this is not actually a showstopper. The system picked it up automatically because it's a very thin line that is technically on the top copper layer, but they'll recognize it as a board dimension layout and treat it as that. So you actually don't have to worry about this issue. What you would be worried about is if it tells you about two copper traces being too close to each other or too close to the edge of the board. We didn't get any of that. These are just, even if we look, there's exactly 4 violations because there's 4 lines going around the board. So that's all it is, and you don't have to worry about it. If you go back to the email you got from them, you'll also see that they offer you a quote, and you can talk to their CAM department directly to ask them questions or if there's anything you don't understand. And I highly recommend you take advantage of that, either with Advanced Circuits or with any other PCB manufacturer. And here the layout for various quantities with given lead times, how much it might cost by the standard spec. Advanced Circuits is not the cheapest one out there, so let's see what other options we have. If you go back to Eagle, you'll see that there's actually a PCB quote option up here. If you click that, remember we clicked on it earlier to get our dimension information, you can click here to get a PCB quote. And this runs right through the Element 14 PCB prototyping service, and it'll pass you straight through to some PCB fabrication services. So we can select that, We can look at Pentalogics. These are the guys, remember, who made that Gerber viewer who you were just looking at, and Sunstone. They're both great options. Both make great circuit boards. Again, there's lots of options for who you can use to fabricate your boards. So we could do a quote with Sunstone, for example. And it'll ask you for how many boards you want, what kind of lead time you have, input the board size in inches again. Finished copper, 1 ounce is usually common for most boards. You could specify the number of layers, all these things that you know about your circuit board. And you can get a quote, and they'll kind of walk you through the next steps. That's pretty much all there is to it. So that's basically it. You output the Gerber files, choose your board fabrication house of choice, send the zip of the Gerber files to them, and then they're on their way. They produce your boards, they send them back to you. You order your parts from the bill of materials that you created, and you are good to go. Okay, so that's basically everything that you need to actually get a circuit board produced. We started off in the first video with making the schematic, then you learned how to do the board layout, and now you've learned how to generate a bill of materials and generate the output files that you actually need to send to a fabrication house to get them to produce your board. Of course, I can't walk through the exact procedure for every board house because if you're in different countries or even different places around the US, you might want to use different options. Search around for what's the cheapest, what works out the best for you. If you don't have an issue waiting a really long time for boards, like on the order of weeks, I would also highly recommend Seed Studio, Seed spelled with 3 E's. I'll provide a link to them. They're based in Southeast Asia, so it obviously takes a while for you to get the boards back, but they're very cheap for low volume prototyping. There's also all kinds of batch PCB services that I'll also link to that make it easy to get small quantities of boards put together fairly cheap within the US and a pretty quick turnaround time as well. So there's lots of options out there, lots of ways to do this. Again, this gets considerably more complicated when you have 8 or 10 layer boards with all kinds of crazy signals and huge board layouts and crazy things happening on them. But for simple boards like this one, it's actually a pretty straightforward process. Now that you have the BOM and the Gerbers, you're ready to go out and get everything fabricated. If you want to take the next step and actually have the board assembled for you too, that adds a ton of additional cost, but it's pretty common practice with larger quantities when you start wanting mass producing things. At that point, you would want to output the actual solder layer as well that specifies the solder paste layer that specifies where paste would go down from an automatic paste machine so that then a pick and place machine could automatically place parts appropriately. And that adds an additional layer of complexity as well that I won't dive into in this video. But that's basically the gist of it. I hope that you guys enjoyed it. Hopefully there'll be an additional video coming that talks about making custom library parts, although I don't know an exact timeline on that, but I hope I'll be able to bring it to you all soon. If you have any questions, always remember to hit me up on Twitter. SciGuy14 on Twitter is by far the fastest way to get in touch with me. If you have a lengthier question, you can contact me through my website, jeremyblum.com, but I don't guarantee fast response times. Okay, I hope you guys liked this video, and I look forward to teaching you again soon. Good luck with your circuit boards.